Uh, I select the title to be from CLTP. CLTP, as Mrs. Ray Kawashima mentioned, stand for CubeSat CanSat Leader Training Program. So we have till now 14 cycles. So from CLTP1 to CLTP14, 15 years journey in space engineering education as a participant and as a teaching assistant as well as educator. I'm currently a professor and the chair of Aerospace Engineering Department at the Egypt Japan University of Science and Technology, EJAST. This is a quick introduction. I think Charleston already go over it, and the things I would like to say here is that starting from CanSat, I was able to work on a real satellite project. In Nihon University, I worked in Nexus, one new CubeSat, which was launched in 2019. And I also could able to contribute to another satellite launched 2024, which is a microsat at the Egyptian Space Agency. I was honored to serve as a deputy CEO at the Egyptian Space Agency for 3 years. And the first thing I would like to say here is that when I joined CLTP1, I thought I was attending a short satellite course. I never imagined that after 15 years later, CLP would still be shaping my career and my teaching philosophy, and as well as international collaborations. And I will say why. In this slide, this is the cycles which I participated on site in Japan during CLTP1 as a participant in 2011, and during also CLTP2 as observer at Nihon University. CLTP1 was at Wakayama. It's on the south side of Japan. And CLTP was in Chiba near Tokyo. And I could also have another opportunity to join CLTP7 in Hokkaido in 2016 as a participant this time, because I have ambitions to work on the kit, CanSat kit. And I was lucky also to join CLTP8. This cycle was the first cycle to use CubeSat, Heptasat for training. It was in 2017, at the time at Nihon University in Chiba. So in the upcoming few slides, I would like to give a quick background about the program as well as the space engineering in general, and to map what is the relationship between the CanSat and the real satellites. So the CanSat training program is to prepare future educator of CanSat through hands-on training and different activities. So when they return to their home countries, they will disseminate the knowledge that they gain during their training in Japan. And as Mrs. Kawashima mentioned, one of the very important intended learning outcome of CLTP is to spread the knowledge. And the vision of UNISEC-Global is by the end of 2030, let's create a world where university students can participate in practical space projects in more than in all countries. I'm sorry, this is a typo here, in all countries, because the old one was in more than 100 countries, but in all countries. And the CanSat leader training program with the is the tool or the apparatus that could achieve this vision. Student also will be able to experience the whole AIT process of satellites, and they will be able to realize and design and develop a payload during this training. And also, very recently, they could able to not only learn but also practice teaching to high school students and non-engineer participants. And then when they return to their home country, they disseminate the technical knowledge they gained in Japan. This is a quick overview, and I think most of you know the different segments of space systems. We have a launch segment, space segment, ground segment. And if we focus our attention to the space segment, which is basically the satellites, it consists of payload and another 7 other subsystems. Why I'm telling this? Because in CANSAT or CubeSat, we can map this subsystem to what we have on these educational tools. Like electric power subsystem, for example, the communication subsystem, structure, onboard computer, attitude determinations, and so on. So the idea of CANSAT was proposed by Professor Bob Twiggs back in 1998 during a conference as far as I remember, in Hawaii. And at that time, Professor Bob Twiggs was a professor at Stanford University. And his motivation was that to go outside the classical classroom lecture and knowledge, like a spoon feed. It was at that time spoon feed approach, and to have to let the student build something. And this thing is so close to the satellites. And he stand up and by a can in his hand and say, let's make a satellite out of this can. He tried to launch this satellite, but it wasn't successful to launch it into space. So they come up with the idea of suborbital launching in Nevada using amateur rockets. And from here, the ARLIS started, which stands for a rocket launch for international student satellites. It's annual activity in September each year, where students participated in this competition. And as I mentioned, the CANSAT is a tiny electronic payload, which has a subsystem very similar in most of it to the subsystem on board the satellite. And the good thing here is that you could able to develop and launch and test and launch the CANSAT in a short time with I mean moderated budget, not like space projects. And the participant and the student can learn actually from their mistakes. So this is I mean, indispensable tool for education and for courseware as well. A typical mission for CANSAT is, as I mentioned in ARLIS, use the amateur rocket to launch it to around 3,600 meters and then it drop using parachutes, and it stayed on the descending phase like 10 to 20 minutes. During this descent, the CANSAT conducts the mission and also communicate with the ground station and send the telemetry and the other payload data. This is a very typical, I mean, communication window with the real satellite. Usually, LEO satellite we will have a communication window of 10 minutes. So when students, practice such communication and development, they are doing very similar things to what they will do with the real satellites. Another option for the CANSAT deployment is by using balloons or drop it from high-rise buildings, so or even UAV or drone. So there is many, tools and equipment that could be used to drop the CANSAT and conduct the mission. So this is a basic CANSAT. There is another version of this CANSAT, which we call it compact or compacker or flight pack. So where the CANSAT try to go to a specific location on the ground during its descending phase or even after touchdown the ground, and then the rover to a specific point. This is a challenging compared with the basic CANSAT because you have to have a navigation and control, and they usually use GPS communication with the satellite to navigate and to reach to the target point. So this table actually shows the comparison between the educational kit like CANSAT and the real flight model. So both of them has electric power subsystem, both of them has a communication. The control depend, as I mentioned, for the compacker, usually we have a control and navigations, but for basic CANSAT, it depends also on the mission. The command and data handling or the onboard computer, both of them has these subsystems, structural as well. Both of them has a structure and it's subjected to a kind of shock load or launching load. Thermal educational kit is not have a thermal control because it is a suborbital flight, but for flight model it has a thermal control subsystem. Regarding the testing, both of them subjected to vibration and thermal depend, as I mentioned, on the mission, and for thermal vacuum testing, we don't do this testing for the CANSAT as well as radiation testing, but we do so for the real satellite. Development CANSAT or the educational satellites, it's moderated time. It can goes from 1 week, for example, up to 6 months if it's a compacker. But for CubeSat, for example, it might take from 1 to 2 years. And for the operation, here it could operate it up to tens of minutes. But for the flight model, it might be order of years. So when it is started, or from where we got the idea of this practical space engineering, Mrs. Rei Kawashima paid us a visit at Cairo University back in February 2010. And at that time, the courseware actually was too theoretical. Standard using textbook and models, mathematical model and problems. So it doesn't come to our minds that is this kind of activity like developing CANSAT or developing a student that developed the CANSAT and the CubeSat, like what UNISEC Japan doing. So it was for us like very motivating discussion with Mrs. Rei Kawashima, and from here that we promised her that we will send young professors that could attend the CLTP 1, and I was lucky to be nominated for this trip at that time. And CLTP 1, as Mrs. Rei Kawashima mentioned, it was in Wakayama. Actually, it was 1 year, 1 month duration, and we have to develop and launch the two version of CANSAT actually. The basic CANSAT is in within 1 or 10 days, and the advanced or comebacker CANSAT. The basic CANSAT we launched it from in Wakayama prefecture, and it was planned that we will go to Tokyo to attend the first mission idea contest at the time in March 2011, and launch the compact concept from an island very close to Tokyo. I think it's Oshima Island in Tokyo. So this was the plan. And this slide gave us, quick outlook about the CLTP. The coordinator was Professor Hiroki Akiyama, professor at the University of Wakayama. And his teaching philosophy, he kept saying to us during our participation in the CLTP1, the animal spirit, and I didn't know what does it mean at that time, but it means that you are doing everything by yourself. You have to be self-motivated, initiative, and do, focus on what you are doing. So the content of the program at that time, it was a set of lectures, technical lectures by prominent professors and engineers, and hands-on training. It was, of course, it was the very first time, and it was the first approach to do this. And the duration, as I mentioned, it was slightly more than 1 month, because we plan to attend the mission idea contest and go to the island in Tokyo. 12 participants attended this cycle from Turkey, Egypt, Bangladesh, Vietnam, Guatemala, Algeria, Australia, Mexico, Nigeria, Peru. So it was a really international team. And the platform, there was no kit at that time. So we built our CANSAT from scratch. We built two versions. One is the basic CANSAT, which I mentioned. It should be deployed by an amateur rocket from a high altitude and descend. And while descending, it measure and collect data and send it to the ground station. And another CANSAT, which is a compact, whether it's flypack or rover pack, and this was planned to be on to do the testing for the compactor on Tokyo, island near Tokyo. And this is a timeline. We arrived on February 12th, and of course, as Ms. Kawashima mentioned, it was like a shock for us. It was heavy snow at that time. After the welcome ceremony, we have to go to the hotel from the university, and at that time, heavy snow. They told us that this is snow never occur in more than 10 or 20 years at that time. But we did arrive after almost 1 or 2 hours to the hotel. And then we started the set of lecture about the embedded system and microcontroller. And then Professor Akiyama tell us, okay, now you have a background about microcontroller, and here is a set of sensor you can use the animal spirit to develop the CANSAT, which will be launched on after 1 week from almost less than 1 week. So we have to come up with something that we will put in a rocket and drop it from the altitude. And of course, the 12 person was divided into basically 3 teams. And these photos show my teams, Masoud from Algeria, Mansour from Turkey, and Vanichi from Bangladesh, and myself. And here we stayed after very close to the midnight, finishing our CANSAT, and we launched it successfully on February 18th. After that, again, use your animal spread to develop the comeback. And we developed a hybrid rover and airplane or flight CANSAT flypack. It combines the flypack and the comeback. And we tested it successfully on March 10. Of course, the photo show us near the balloon. We tested using the balloon at Wakayama, and the plan was to go to Tokyo and go to an island near Tokyo called Oshima Island and launch it using a Amateur rocket. And we, of course, we bought the different electronics from Nihon Pashi in Osaka. And on March 11, 2011, it was a closing ceremony before we go to Tokyo. So this is a, very, strange coincidence, because what happened while we were staying at this nice restaurant, we observed. So this is the ceremony at the restaurant. It was in near a sea, and what we observed a sudden change in the water level. And after this sudden change in the water level, there is a microphone all around saying a lot of things in Japan, and we asked Kiyama Sensei at that time. He said, "Don't worry, There is a small earthquake happened in Japan, and this is usual." And the thing is that we plan to leave on the night of March 11 to Tokyo, and we were worried actually. And he told us, "Don't worry, we will go to Tokyo, and the earthquake is not in Tokyo. It is in far from Tokyo. It's in Fukushima." And actually, what we did is that we came closer to the earthquake, and this is we witnessed actually. We witnessed extraordinary actually reliance and professionalism and the kindness of the Japanese people as well as CLTP organizers. Of course, it was challenging to us while we landed in Tokyo. We found a lot of, challenges, whether to ride a subway or train, because things is disturbed by the earthquake at that time. And in the memory of Professor Isao, may he rest in peace, was one of the participants in CLTP 1. We respectively remember our CLTP colleagues and the friend, and Professor Isao was one of them. He's from Mexico, and he passed away in November 2015. And of course, as I mentioned, the launching was cancelled. And also we attended the very first day of Mission Idea Contest, and UNISEC office helped most of us to get an earlier flight for those who want the earlier flight to return to their home country. So as reflections, as I mentioned, it was very tough for us to develop these two CANSATs in a 1 month, and it's enabled us to tackle complex engineering problem and develop system engineering mindset. And we gain deep insight into the practical satellite engineering, and we inspired by this kind of project-based educations. I also initiated at the Cairo University CANSAT training program in the same year to deliver this knowledge to the undergraduate students. And also our department, Aerospace Engineering Department at Cairo University, established the Space System Technology Lab, which is a student-centered educational laboratory. And as I mentioned, we could manage and with confidence to tackle the complex engineering challenges. And the networking that we built on the CLTP actually promotes the international cooperation and the global network. As I mentioned, I was lucky to rejoin CANSAT as a participant also at Hokkaido University in CLTP 7. The program coordinator is Professor Totani from Hokkaido University. And at that time, the content is duration, it's getting shorter. Instead of 1 month, we stayed like 10 days. Before these 10 days, there is an online set of lectures that every participant has to listen and to have exams and homework about this, the content of this lecture. And then they travel to Japan to attend the hands-on training period. And it was from September 21st until October 1st, 2016. And there were 9 participants from Nepal, Egypt, Myanmar, Serbia, Dominican, and Mongolia, and Peru. And we use the ICANSAT training kit developed by Professor Sahara from the Tokyo Metropolitan University, and others also contributor from other Japanese universities. And this slide show the different cycle and what is used for each cycle from CLTP 1, 2, and 3. It's basically building the CANSAT from scratch, and started from CLTP 4, 5, 6, 7. 4 cycle use the ICANSAT. And the ICANSAT itself, it shows development. The very matured version was actually on CLTP 7. Earlier version was used in CLTP 4. In this CANSAT kit, we have a number of PCB or printed circuit board. Each PCB means a specific subsystem on a real satellite. So we have battery for PCB for the battery, PCB for the communication, PCB for the camera, and PCB for the sensors. And to give students the idea of designing or developing their own payload, there is a user PCB, which is empty, and the participant has to think about a specific mission and to use a specific sensor or actuator to place on this user PCB. And it's shown in this photo beneath the battery board. And I would like to show you a video about the CLTP 7 experience, which was in Hokkaido at the time. The assembly of the CANSAT was conducted at Hokkaido University, and the launching was done by building our own amateur rocket near in a place in Hokkaido as well. So I will play the movie. It's about a 5 minute movie. It summarizes all the activity that has been done in CLTP 7.
Hello, Dr. Khalil, can you hear me?
Excuse me?
Yeah, we can't hear any audio from the
Okay, I
video.
mean, just there is no, it's a song actually. So,
Okay, okay.
okay,
All right.
okay, please. So this is, I will just give my comments on the video. We are uh, assembling the CANSAT first, and then we did the drop test here in in the from high-rise building, and then we did also vibration testing for the CANSATs using the shaker at Hokkaido University. And we analyzed the data. We also did the thermal cycling for the CANSAT. And then we went to another place on the Hokkaido to build our own rocket. So this was very interesting for me. And we did the drop test for CANSAT using the drone as well as the rocket. So this is the testing ground in Hokkaido. And this is a drone drop of the CANSAT using the drone. It takes something like 20 to 30 seconds to touch down. Each participant built its own rocket with a solid propellant engine, very tiny. It could raise up to around 100 meters, and then it can separate from the rockets and conduct the mission while it is descending. So this rocket is basically from paper-based material. And then there was a two parachute, one for the rockets and the other is for the CANSATs. Or here is the CANSAT in descending phase. And this is the final uh, shot for the CANSAT. And this is a participant during the closing test close. Okay, thank you. And I could, after completing the TLTP 7, of course, I had also the opportunity because at that time I stayed in Nihon University for 1 year as a visiting professor. And so I attended CLTP 7 and I could able to also participate in CLTP 8 as a teaching assistant because I was working with Professor Yamazaki to revise the design of the cube satellite, which called Heptasat, as well as with other students. And the style or the content of this CLTP8 was the online set of lecture and hands-on training in Japan for also 10 days. And there were 8 participants from Nepal, Egypt, and Bolivia, Salvador, Malaysia, Japan, and Turkey. And we used the Heptasat training kit. And this slide show the different CLTP cycle and where is the ICANSAT is used and the building it from scratch as well as the cycle. So here it's around about 7 cycle used the heptasat from CLTP 8 in 2017 until the last year is 2025 is used, and heptasat itself is developed. There is, as far as I remember, 2 versions of the heptasat developed during this offering. And this slide show the heptasat and the ICANSAT. Both of them actually has a user board, as I mentioned, to for the participant to innovate or create their own mission, same way as the heptasat. Heptasat is based on the seeds. It's one new CubeSat launched by Nihon University in 2006, and it was based on this cube satellite, but in a reduced version. So it has solar power, EBS subsystem. It has a separation switch. It has a more powerful onboard computers and a lot of built-in sensors. So its capability is much more compared with ICANSAT, and it's a real or not. The size is very similar to the CubeSat, and student or participant focused mainly on the AIT as well as the payload development. This slide show my engagement in CLTP program through the years. In red, in CLTP 1, CLTP 2, 7 and 8, I participated on site in Japan. I was honored also to serve as a moderator for the online lecture series for CLTP 5 and 6, as well as 7, 8, and until last year. I was serving as a moderator for the online portion of the program, and this is allowed me to interact with almost every participant joining the program during these periods. So this photo show we have now, as Kawashima-san mentions, around 159 graduates from the CLTP from 63 countries all over the world. Actually, it's all above our expectation to have such talented professors have the knowledge, and they could disseminate such a knowledge to their students in their home country. This map showed the distributions of CLTP graduates worldwide. Of course, most of them are on space emerging countries. Of course, some country was lucky, like Egypt. We participated by many participants, not only me, but a lot of other colleagues, also in Mongolia, in Mexico, in Vietnam, in Philippines, sent more than one participant, and actually UNISEC was very supportive in this regard. I would like also to thank the managers, coordinators, and instructor for the CANSAT leader training program. Actually, they supported the execution of the program through these 15 years, as well as in every aspect, actually, whether it is online lecture, whether it is the preparation of the quizzes, as well as the hands-on training part. This is just to name a few. I mean, there's a lot of people also worked behind the scene, like students and laboratories that hosts the CANSAT leader training program, the graduate students as well, the administrative staff of UNISEC Japan. But to put all this, it will take a lot of space. So I would like to say thank you to all of who supported this program. And bringing CLTP philosophy back home, as I mentioned, we established the Space System Technology Lab. And as I mentioned also at the beginning, I served as the Deputy CEO at the Egyptian Space Agency. We could able to replicate the ICANSAT or have a version very close to ICANSAT. We call it EXA CANSAT. And I also witnessed the development of a one-U cube, educational cube satellite. We call it Space Keys at the Egyptian Space Agency. I will show later a slide about both of these kits. CANSAT training program was running since 2011 until the present time. And we also conducted several CubeSat workshop here in Egypt with the support from UNISEC Japan and Nihon University. And there is a mentoring of student activity in terms of extracurricular activity in the university and the project-based learning. This slide shows the EXA CANSAT, which we developed as the Egyptian Space Agency for outreach activity. And also, we distributed this CANSAT kit to the STEM schools. So we have here science, technology, engineering, mathematics school. It's basically, the education is based on the project-based learning. And they are now utilizing this tool kit for education. We developed around 100 kits and we distributed it to most of the STEM university and other senior high school universities. This slide shows the Space Key. It's one new educational satellite developed by the Egyptian Space Agency through the support of the Academy of Science and Technology in Egypt. And we produced around 40 kits distributed to 25 universities and one STEM school, as well as 6 African countries. It's slightly complicated compared with the Heptasat, but it's based on the NARS Cube. It's a one-U cube satellite launched by the Egyptian Space Agency. So they try to make the educational version out of it. So it becomes complicated, but it's for educational purposes. It's still very comprehensive. And we prepared something like a set of experiments that students can conduct to the assembled version of this kit. And of course, for advanced level, they could develop their own payload, and they can work also with the software which you already provided to the participating universities. And my current activity, actually, I'm honored to be the founder and chairman of the Aerospace Engineering Department at EJUST. It was approved by the Egyptian Supreme Council in 2024. And our very first batch of students will start studying the program next spring, next autumn, from September 2026. Also, we introduced some space system educations in other different programs, like elective courses, for example. And we could also able to organize CubeSat and CanSat workshop here, and inviting other researchers all over the Egypt to attend this workshop, and also conduct capstone projects and graduation projects and research with other discipline within the engineering and science. These photos show the latest CubeSat workshop. It was conducted February this year at Egypt Japan University of Science and Technology, and the fund was from the Science Technology Development Fund from Egypt, and from Japan Society for Promotion of Science from Japan. And in this workshop, around 30 participants attended this workshop. These 30 participants, we had around 11 teams within this participant. Each team has HeptaSat kit, so they acquire the knowledge of assembly, integration, and testing, and they, did the payload development as well as the software. It was for less than a week, and it was very, very successful. And the participant not only from EJUST, but the participant also from Egyptian Space Agency, Cairo University, National Authority for Remote Sensing and Space Sciences, Space Technology Center, around about 10 institutions all over Egypt whom are interested in space systems. And advice for future participants, especially from the emerging country, as I mentioned, simple start always make a big difference after after a certain time. And the CanSat and the CubeSat and CanSat and things like desktop competition like Mission Idea Contest, it will not cost that much, but it will make big difference during your start. And take the initiative in learning, and of course international collaboration is a key here, because it brings different culture, different educational methods, and it can help a lot during the evolution of your program or your development. And maintain long-term connection with CLTP and UNISEC community. And very recently, the UNISEC-Global launched the IoT constellation missions, which is a very important milestone in the UNISEC activity. And many countries and participated in this IoT, and the connections is very important to know about this activity, to know about how to share and how to engage in such activity. Also, try to contribute to developing space education in your country through disseminating the CanSat education or CubeSat education, or visualize your results in terms of joining competition like a Mission Idea Contest and so on. And at the end, I would like to say that as CLTP celebrates its 15th anniversary, I am honored to have witnessed its evolution from the very beginning. The impact of CLTP will continue through every participant who carried its spirits forward. Thank you very much for your kind attention.